Okay guys, today let's talk about the nitration of benzene. This is going to be another example of electrophilic aromatic substitution where we use one of the pi bonds on a benzene ring to attack some kind of electrophile and ultimately add something onto the ring. In this case, our final answer is going to be a nitro group, an NO2 group onto the ring. The reagent for doing that is HNO3 over H2SO4. And let's see if we can't walk through this mechanism. As usual, this inside the brackets is what we call a sigma complex or just benzene resonance. So first thing that happens is this pi bond is going to reach out and attack that nitrogen. That's too many bonds for nitrogen, so this oxygen is going to resonate up top like that. NO2 looks like this. Usually you're going to need to know that on test day. Sometimes it'll come into play on whether something can be added, ortho, meta, or para. Anyhow, let's see how this sigma complex is going to look. So you've got your NO2 here, and as a result of these two electrons now being tied up into this blue sigma bond between this carbon and the NO2 group, that's going to leave this end devoid of one of the fourth bonds, and as a result, that's going to be where your carbocation is. Any kind of sigma complex is just benzene resonance, right? So this pi bond is going to flip over so we can balance that charge out within the ring. Well, so then you're going to have your carbocation here, your NO2 group here, and then of course you're going to have some resonance here. So this pi bond will flip down, so now my carbocation will be up here, NO2 group still up here. At some points we've got a water molecule that came from earlier on in the mechanism. Usually it's very rare that you see this on test day anyway, so I've kind of omitted the first step here, but water is going to act as a base like this, and is going to deprotonate that hydrogen there. And then of course your two electrons, which did make up that C to H bond, they're going to kind of collapse towards that carbocation right there, restoring aromaticity within the ring, aka restoring that third pi bond. If you found this video helpful, but you need more in-depth explanation or see a lot more practice problems worked out, you can find full length version over at orgogoat.com. Please like, comment, subscribe to our YouTube channels and all of our videos to help find and reach more students like yourself. Tell all your friends what a great tutor you have. And if you're interested in private tutoring, or if you want to see a concept explained that you don't see on our YouTube page, shoot me an email, orgogoat@yahoo.com.